Hi all, this is Jyoti Prata Haldar, Data Science and Business Analytics Intern at Spark Foundation. This is the task 6 submission, which is prediction using decision tree algorithm. The task is to create a decision tree classifier and visualize it graphically. The dataset that has been provided, that is of iris dataset, and the link for it has been provided over here. The requisite libraries have been imported: NumPy, Pandas, Matplotlib, tree from sklearn, level encoder from sklearn preprocessing. The dataset is loaded into the Jupyter notebook. Then the data is visualized. What we see over here is that there are four features of the flower, which is sepal length, sepal width, petal length, and petal width. The last one, which is the species, is actually the classes in which the classes belong. Now basically we have to classify the data into the classes using decision tree. So we reshape the data, which is the species, because we need to convert it, label encode it. So we label encode the species and then include it into the data.target, which is very much visible in this data frame over here. See the target, which is label encoded of the iris data, say species column. Now we create the x and the y, which is the variable mean features, and the labels. Labels is the y, which is we call it the data, which is the data.target, which is classified label encoded in 0, 1, and 2, and the features, which is sepal length, sepal width, petal length, and petal width. We initialize the instance variable tree.decision tree classifier with a random state 0, and then fit the data for creation of the model. And then there is then we plot the decision tree. Then the code is tree.plotTree, and then we give the instance variable of the classifier filled with for the color. Then we give the class names, which is the name of the class, and the feature names. This is a tree that is produced, and we can see it on the screen. Basically, it starts with the petal width, where this petal width is less than equal to 0.8. Then it starts the splitting. The main criteria for splitting is the Gini impurity. We see the Gini impurity over here is 0.667. The decision tree classifier at the back end, it calculates the Gini impurity, and it ensures that at each level the total Gini impurity decreases. Now if you see the Gini impurity over here, it is 0.667. When it's split, the 50 out of 150 sample, 50 sample goes over here, and 100 sample goes to this box. Now over here the Gini impurity is 0 because it is the leaf node, and over here the Gini impurity is 0.5. Now if we calculate the Gini impurity of this level, it is coming to 0.33. that is calculated. I've calculated otherwise. And again, in the next step, as we split it from here, the Gini impurity in this one, in the green box, where the 54 sample out of 100 sample is taken, is 0.168. Again, the Gini impurity on this purple box is 0.043. But for this level, the Gini impurity is coming to 0.1105. Now this is the main concept of decision tree, that at each level the Gini impurity or the splitting criteria decided whether the decision tree is split basis the reduction in the Gini impurity. That is the main criteria of splitting. This is what we see over here, and at last we see that all the classes are classified, and we see over here, see this is a leaf node where we see that finally the class number 2 is classified. Over here the last one, which is iris virginica, is classified. Here iris versicolor is classified, and here the iris setosa is classified. So at each leaf node we see that the classification is complete, but the classification goes at various stages, and the main backend algorithm that is taken by the classifier is reduction of gene impurity. Thank you.